Hey guys, welcome to Chem Galaxy. So today I'm going to tell you a very easy way by which you can remember the formulas of the equivalent concepts. Alright, like equivalent concepts means that the concept of gram equivalent, normality and equivalent weight. Alright, and I'm going to explain you these terms by comparing it with their similar terms. Like I will be comparing molecular weight with molecular weight with equivalent weight, moles with gram equivalent and molarity with normality. So by comparing these terms, it will be more easier for you to understand these terms, and it will be very easy for you to remember the formulas basically of these terms. Alright, so now let's start. So as you all can see, the heading is equivalent concept. Alright, so first of all I'm going to compare molecular weight and equivalent weight. Alright, so what is molecular weight? So weight of 1 mole of an atom or molecule or the sum of the atomic mass of its constituents. Alright, so basically what is molecular weight in short term? I am not going into a detail of it, like for example comparing it with carbon 12, taking the relative mass as carbon 12 and then comparing it. So I am not going to get into a detail, but if you want that also, comment down below. I will make a full detailed video on that as well. Alright, I am going to tell you a basic terms through which you can remember exactly what is molecular weight and apply basically in the numericals or while doing practicals. Alright, so basically what is molecular weight? For example, you are taking water. So if you want to know the molecular weight of it, so simply add the atomic masses of the constituents of water. This means 2 atoms of hydrogen and 1 atom of oxygen. So hydrogen, the atomic mass of hydrogen is 1. Alright, so and atomic mass of oxygen is 16. Alright, so 2 into 1 plus 16, which means 18 grams. This means that the molecular weight of water is 18 grams. Alright, so that's all. And this also means that if you have taken 18 gram of water, this also means that you have taken 1 mole of water. Alright, so this is basically a simple term by which you can understand, or a simple way to understand molecular weight. Now let me tell you about the equivalent weight. Alright, because the new concept has been derived, which is equivalent concept, and which is very helpful while doing practicals and basically the titration practicals. Alright, it is very important. It is widely used in these titration practicals. Alright, so it is very important you to understand it. So basically what is equivalent weight? I am not going into a definition. Alright, so the simple term by which you can understand it is that equivalent weight is equal to molecular weight by n factor. Alright, nothing else you have to remember, that equivalent weight is equal to molecular weight by n factor. Okay, now what is n factor? That is a quite big topic. Alright, so I will make a separate video on it and it will be live on my channel on Thursday. So if you don't want to miss it, subscribe to my channel right now. Alright, I will make a separate video on n factor, basically how to calculate n factor for different atoms or oxidizing agents or acids and bases. Alright, so that is a quite different topic and it will be a quite lengthy topic. So if I will include it in this, then the video will be very long. Alright, and I want to make it as short as possible. So basically in this video I am going to tell you only the basic part which you should stick into your mind and you should remember it so that you can apply it. Alright, so basically equivalent weight is molecular weight by n factor. Okay, now let us see further. Basically in molecular weight I have given you some examples also. You can see that water, so 2 into 1 is atomic mass of hydrogen and 16 is the atomic mass of oxygen. Alright, so when you will combine those, add up those, you will get 18 grams. So if you want to know the molecular weight of water, it is 18 grams, and if you want to take 1 mole of water, what you have to do? You have to take 18 grams of water. Alright, now if you take sodium chloride, so basically the molecular weight of sodium chloride is nothing but the sum of the atomic masses of sodium and chlorine, which is 23 plus 35.5, which is 58.5 grams. So basically the molecular weight of sodium chloride is 58.5 grams. Or if you want to take 1 mole of sodium chloride, you need to take 58.5 grams of sodium chloride. Alright, now let us see what is mole and gram equivalent. Alright, so basically mole, the basic formula of mole is that mole is equal to weight of the substance which you are taking upon or divided by the molecular weight of that substance. Alright, which means for example I am taking sodium chloride. So if you have taken, or for example I am taking water. Alright, so if you have taken 9 grams of water, alright, 9 grams of water, So you will place 9 grams in place of weight of substance and you will divide it by 18. Alright, so what you will get? You will get 1 by 2, alright, or 0.5 moles. Okay, so basically the simple formula for mole is that weight of the substance whichever you are taking, for example water or sodium chloride or sulfuric acid or any of the potassium hydroxide, sodium hydroxide, any of the substance. So you have to put the weight of the substance and divide it by its molecular weight. Alright, and molecular weight, you know, the sum of its atomic masses of the constituent of molecule, right? Like the constituent of sodium chloride is sodium and chlorine. So you have to add the atomic masses of sodium and chlorine to obtain the molecular weight. Okay, so this is basically what is moles. Alright, now let us see what is gram equivalent. So basically in gram equivalent, what you will do, you have to do nothing. Everything is same, but instead of molecular weight, you are going to use equivalent weight. Okay, so nothing varies. Okay, so the formula of gram equivalent is weight of the substance divided by the equivalent weight of the substance, right? Because here we are taking equivalent concepts. So by comparing it with the normal or similar terms, so you see in mole we are using weight of the substance upon molecular weight. In gram equivalent we are using weight of the substance upon equivalent weight. Alright, because these are quite similar terms, but the only thing varies is one thing deals with moles and one thing deals with gram equivalents. Alright, so the basic formula is quite same. In moles we are going to use weight of substance upon molecular weight of substance. In gram equivalent you are going to use weight of substance upon equivalent weight of substance. Alright, nothing else varies. So if you compare these terms, alright, then it will be very easy for you to understand the formulas. Alright, and then you can simply apply it because you already know the formula. Alright, now let us see what is molarity and normality. Okay, now these two terms are also can be understood by comparing this. So what is molarity? Now molarity is moles of solute taken in 1 liter of solution. Alright, I am repeating it. Moles of solute taken in 1 liter of solution, which means, so the formula becomes is that moles of solute divided by volume of solution in liters. Alright, the unit of volume should be in liters. So I am repeating it, that the formula is moles of solute upon volume of solution in liters. Now if you want to convert it into equivalent concept, so out of the two terms, which term can be converted into equivalent concept? That is moles. Alright, because the equivalent term of mole is gram equivalent, right? The equivalent term of mole is gram equivalent. So in place of moles of solute, if we place gram equivalent of solute, right? Try to understand. In place of moles of solute, if we place gram equivalent of solute and divide it by volume of solution in liters, then the term will become normality. Alright, so this is how you can understand it. So what is molarity? Moles of solute upon volume of solution in liters. Now what is normality? Gram equivalent of solute divided by volume of solution in liters. Alright, so the normality is just an equivalent term of molarity, not equal or the same terms, they are equivalent terms. Alright, so the moles of solute is being used in molarity and the equivalent term of mole is gram equivalent, so you will be using gram equivalent in normality. Alright, so now let us do a quick revision. So you know molecular weight, so simply add the atomic masses to get the molecular weight of a molecule. Alright, atomic masses of the atoms which constitute the molecule, add the atomic masses, you will get the molecular weight. What is equivalent weight? Molecular weight by n factor, right? And the video of n factor will be live on Wednesday, so do subscribe. Alright, so equivalent weight is molecular weight by n factor. Now what is mole? So basically the formula of mole is weight of the substance upon molecular weight, right? Now if you see in the formula, weight of the substance upon molecular weight, now out of the two terms, which term can be used in equivalent concept? Alright, or can be changed into equivalent concept? That is molecular weight, right? So the equivalent term of molecular weight is equivalent weight. Alright, the equivalent term of molecular weight is equivalent weight only, na? If we talk about gram equivalent, so the formula will be weight of the substance upon equivalent weight of the substance, nothing else, right? The only term will change is molecular weight in moles and equivalent weight in gram equivalent. All right, so the formula of gram equivalent is weight of the substance upon equivalent weight. Now let us see molarity and normality. So what is molarity? Moles of solute in volume of solution in liters. All right, moles of solute divided by volume of solution in liters. Now what is normality? So gram equivalent of solute in volume of solution in liters. So gram equivalent of solute divided by volume of solution in liters. All right, so you see how the terms interchange. All right, you can see how the terms interchange. Basically in molarity we use moles of solute. Now if we want to convert it through a equivalent concept, so in normality we will going to use gram equivalent instead of moles. All right, so that's all. So molarity, moles of solute upon volume of solution in liters, and in normality gram equivalent of solute in volume of solution in liters. All right, same case goes with moles also. In moles we are using molecular weight, and in gram equivalent we are using equivalent weight. All right, so that's it, and I hope I was able to tell you some interesting facts about these concepts and also how to relate them to each other so that it will be easier for you to understand. All right, so that's all for today. I hope you have understood whatever I have taught. If you have understood, do give it a like, subscribe to my channel, and if you have any queries, comment down below. All right, so now I will see you all in the next video. Till then, this is Akash Shukla signing off.